Patterns and nonlinear functions. We're going to jump right into some examples. The first one here, we have the area A in square inches of pizza is a function of its radius in inches. The cost, C, in dollars, of the sauce of a pizza is a function of the weight, W, in ounces of the sauce that is used. Graph the functions shown by the table, and then identify if it is linear or nonlinear. So this first one, we have the area of the pizza. So the radius we know is R, and that would be in inches. And the area is A, and that is in square inches. So now we're just going to graph them to see what we have, see what it looks like. So what I see is if I graph this, so I want to just sketch it out here. Then I'm going to go radius down here. So this is R, and this would be my area. Okay, so then I have to figure out how I'm going to number it. So how am I going to number it? 2, 4, 6. I'll just go by 2's here. 2, 4, 6, 8, 10. Now I need to figure out how I number going up. So this time I got to spread it out a little more. I'm going to go by, I think maybe 25 will be good. So I'll go 25, 50, 75, 100, 125, 150, 175, 200, 225, 250, and that's a good start. I can go a little bit farther when I'm done. Alright, so now I'm going to plot these points. So the point 2, 12.57, so that'd be about right there. It's not very high, just close enough. Then we have 4, 50.27, so it's about right there. Then we have 6, 113, so 113 is going to be up about here. And then I have 8, 201, so that's way up here. And then I have 10, 300. So 10, 250 is here, 300 is going to be kind of way up here. So my line looks like this. That is very clearly not a line, it is a curve. So it's nonlinear. So that would be your conclusion, nonlinear. With this next example, we're going to do the same thing. We're going to graph the cost of the pizza sauce. So the weight is the same, 2, 4, 6, 8, 10. So that is going to be our x variable. And we're going to just go by 2's. And then our y variable would be the other one, which is cost. And we're going to go up by $1. 1, 2, 3, 4, 5. And then we're just going to plot the points. 2.8, so 2 and a little under 1. And then 4, 1.6. It's about right there. And then 6, 240 or 2.4. About right there. 8, 3.2. And 10, 4. So it seems like this one, all of the points lie on a line. So that's going to make the answer a linear, because when graphed, it creates a line. So that would be your final answer. For this last example, we're going to just try to understand the pattern of what is happening in the picture. Okay, so in your notes, you see a drawing of a cube, and what the table shows is that the number of edge blocks is first 1, and then the total number of blocks is 1, then the edge blocks is 2, and the total number of blocks is 8, as you can see is happening in the picture, then 3, 27. So we need to figure out how do we get those numbers. So we need to extend this pattern. So if we put 4 blocks on the edge, then we're going to have 4, 4, and 4 going all the sides. So if we were to find the volume, which is essentially what we're trying to do, we'd take 4 times 4 times 4, which is 64. So we should have 64 in the fourth one, and then 5 and 5 and 5 on the next one, which would be 125. So that would be the extension of the pattern, and now we need to explain in words what is happening. So what we are actually doing is we are taking the total number of blocks and that is going to equal what? What is that going to equal? What did we do? We did 4 times 4 times 4, 5 times 5 times 5. So theoretically that should mean that 3 times 3 times 3 is 27, and you will find that that is true. 2 times 2 times 2 is 8. 1 times 1 times 1 is 1. So that pattern is working every time. So what we're going to do here is explain that we take the number of edge blocks times itself three times. Okay, and the next step is to find an equation to describe this situation. So we want it to be y equals something. So we want our total number to equal something with an x in it. So what did we do? We took that x value times itself 3 times. X times x times x. So if we simplify that, we would have y equals x cubed. So that would be your equation. Finally, we have to graph it so that we can tell if it is linear or nonlinear. So I'm just going to sketch out a quick graph with my x and my y. So this would be the edge blocks. So that would make it 1, 2, 3, 4, and 5. And then when I go up, I gotta get up to 125. So that's gonna start. I'm gonna go by 25s. 25, 50, 75, 100, 125. And then from there, I'm just going to graph that. That's the total number. So sketch out the graph. So 1, 1, so that's going to be like right there. We're just barely above. 2, 8, up a little bit higher. And then we have 3, 27, just a little above 25 there. And then we have 4, 64, jump up a little bit more. About halfway in between there. And then 5, 125, coming all the way up here. So now if I look at that graph, what is happening is I'm starting here, kind of curving up. So it is a curve. So because it's curved, it is nonlinear. So that would be your final answer. It is a nonlinear function because it is not a straight line. Those are your notes over patterns and nonlinear functions. Go through your practice problems so that you understand how to develop these equations and explain these equations, and then you can be ready for your quiz.